coefficient of x to the 12th in the expansion 3x minus x squared plus x to the negative 1 raised to the 10th power. So note that the coefficient is going to be of the form n factorial over I factorial, j factorial, k factorial, and then it's going to be 3x to the I negative x squared to the j, x to the negative 1 to the k, where I plus j plus k is equal to n, in this case 10, because that's the exponent. So simplifying, if we just focus on this right here, we have 3 to the I times x to the I, and then negative 1 to the j, x to the 2j, because x squared to the j is just multiply that, and then times x to the negative k, the negative 1 multiplied by the k, and then we'll have the 10 factorial, I factorial, j factorial, k factorial. And then we're going to, let's see, we'll have 3 to the I, negative 1 to the j, and then for the x, we're going to add the exponent. So we have I plus 2j minus k. And so we want to find the coefficient of x to the 12th. So I plus 2j minus k has to equal 12. Okay. And we know that I plus j plus k has to equal 10. So if I add these two, we have 2i plus 3j is equal to 22. And now we can solve for j if we want. So j is going to be 22 minus 2i over 3. So we just solve for j in this equation. So basically, we want to try different combinations of I and j. I guess really I, so that j is going to be an integer. So for example, if I is 1, j is 22 minus 2 times 1 over 2, or sorry, over 3, which is just 20 over 3, and this is not an integer. So we cannot consider this combination. When we go to I equals 2, we have 22 minus 2 times 2 over 3. That's 18 over 3, which is 6. And so this is an integer. So we'll just keep going. We'll try I equals 3 all the way up to I equals 10. So I will save some time and I will not, I'll just give you what j is. So when I is 3, we have j is 16 over 3, and then 14 over 3, 12 over 3, which is 4, and then 10 over 3. So this is just going in a pattern. You're subtracting by 2 over 3 every time. So 6 over 3 will be the next one, which is 2, 4 over 3, and then 2 over 3. So 4 works, and then 2 works. So just to write it out, we know that I plus j plus k equals 10. So we're just going to write in the order pair form like this. The first one is I equals 2, j is 6, so then this has to add up to 10, so we need 2 more. We have 5 and 4, and then 5 plus 4 is 9, so we need 1 more. And then we have I is 8, j is 2, so k has to be 0. So these are the two cases that we have to consider. And so we need to plug it in. So basically plug it in over here. So we have 10 factorial over 2 factorial, 6 factorial, 2 factorial. And then, actually, yeah, so we have 3 squared. And then negative 1 to the 6th, x 12th, plus 10 factorial. Now we're going to plug in 5, 4, and 1 for I, j, and k. So it's 5 factorial, 4 factorial, 1 factorial. That's 3 to the 5th, negative 1 to the 4th, x to the 12th. And then finally, you have 10 factorial over, we're going to use 8, 2, and 0. 8 factorial, 2 factorial, 0 factorial. And so for this, the first one, we get the coefficient of 11,340, and then x to the 12th. The second one, we get 306,180 x to the 12th, and then the last one, we get 295,245 x to the 12th. So adding these all up, we get 612,765 x to the 12th. And because we're only interested in the coefficient, that's going to be 612,765. And that is the final answer.